So, again, we talked about, I was trying to hint at, we didn't really cover it, but why am I interested in looking at the biology in a stream versus sometimes the chemistry? So this meter right here, there's an electronic meter in here real fast. Real fast. So this here, I have electronic equipment that will take measurements of pH and dissolved oxygen and different kinds of things like that, the amount of nutrients in the water and stuff like that, conductivity. I can do that with this piece of equipment. It's what's the problem with doing that? I come in, dip this probe in the water. Say we have a spill of something, a toxic chemical upstream a couple of days ago. I don't hear about it, the neighbors report it or something, and we come by a couple days later and I take some measurements with this. What do you think? Will I necessarily detect that problem in the water?
No.
You may or may not. I mean, it depends on what you're collecting. Ohio EPA is very good. They collect big water sample stuff and they send it to laboratories, and they probably could, depending on what it is, but something like that, rudimentary kind of water quality chemistry stuff, you probably won't detect what's going on. What if I come back a week or two later and I start looking at the fish and the bugs in the stream? What do you think? They may show me a better indication of what's going on if there was pollution in a stream a couple weeks ago or a couple of months ago or last year, or an ongoing kind of problem in a stream. So the biology is a kind of a better long-term indicator of what's going on in an aquatic system. So that's why biologists are interested in sampling fish and amphibians and invertebrates in streams. If we were doing a real survey like this, we would have a section of the stream marked out, 200, 300 feet, whatever the protocol calls for. I would come through here. This is called a backpack shocker, and it's real good for smaller streams like this, maybe even a little smaller, it works well. There are all kinds of ways of going about sampling. You distance, you mark your distance out, you time it, you go through it, and then you tally up, you count all the different organisms, the fish, how many different species you have, and then there are different metrics you can plug those numbers into and come up with an overall score for a stream, something like that, and that's how biologists kind of evaluate the health of streams or things like that. And if you want to talk more in detail about that, I'm more than happy to do that, anybody that's interested in stuff like that. This is a backpack shocker. There are all kinds of ways. There are big boat shockers. I've worked on those for a number of years out on Lake Erie and bigger rivers around Ohio. That's a lot of fun. You get great big fish. There's also generators you can haul around and do something called long lining. That's fun too. A little bit bigger rivers, like the main stem of the chagrin, you can just long line, and that's a very effective way of sampling. But basically, this little backpack shocker, it has obviously a power source here. This is 12-volt little battery. You hook it up into this transformer here. I can change the wavelengths, change kind of the output of the battery up to 300, 350 volts. You can do this thing has a couple little settings on here that you can kind of change the way it pulses out electricity, and it works better for certain kinds of fish. This is your anode, so this is the positive, that the electricity will come out of this right here. This is the wand, so I'll be pushing down on this button. Electricity will flow out of there into this cathode here, out here, and I'll have that behind me. I'll usually have a crew of 2 or 3 people is real helpful. A couple of guys that have waders on, or girls that would like to participate, more than welcome to come in. If you have rubber waders on, you obviously have to be protected. Water and electricity aren't generally a great combination, so you got to be protected with rubber boots or waders like we're wearing here today. I'll get in. What I need is this green bucket here filled up about halfway, 3/4 of the way with water, right? And then I will start.
We always want first.
Pardon me?
Take what's in the bucket out first.
Maybe.
Oh, might be a good idea.
Dump it all in the stream.
Yeah.
Okay, sampling streams, you always want to sample and work going upstream. Do you have any idea why? Why would we?
So the fish can float away.
Well, for one thing, fish would be faced, upstream. You can kind of sneak up on them a little bit better. But also, if you're stirring things up,
Like these
guys
guys.
back here, if it's get into a little bit of silt or mud, and you're not going to be able to see if you're working downstream necessarily what you're sampling with fish. Okay, so you want to work upstream. There's all kinds of interesting techniques you can use. I mean, you can just have a couple of netters like this with me on either side of this thing. I've been playing a lot with using seines and shocking as well. You can shock fish. People will set up a seine down below a riffle or something. You just zap the riffle and everything goes right down into a seine, and that's a real effective way of getting certain species. Do you guys cover the kind of morphology of streams and different habitats in a stream? Can you guys tell me, so the flowing water over there rippling over those rocks, that has a certain name.
Ripple.
Riffle.
Riffle.
2F, yeah, very good. So that's a riffle. Why are riffles not good in streams? What do?
They provide a habitat for the
oxygen.
Yeah, anytime you're stirring up water like that and creating bubbles, what? You're putting more oxygen into the water.
Thanks,
So,
guys.
good job. All right, and it flows into more or less a little bit of a pool, slower water pool where it's quieter. This is more of a run right here where there's actual flow coming through. There's a real nice pool where that tree is fallen down over there. That's a deep, slow water area. It provides protection for fish, deep water. Those are great places to sample for fish. But every species in the stream is going to kind of partition themselves. I don't know if you talked about niches in streams, okay? Certain fish will live in certain habitats. So a certain kind of fish will live in the run, and certain fish, and we'll get them, are going to live in that riffle we just talked about. Certain fish will separate themselves out and live only in pools. Why is that? Why would they do that? Think about maybe, I don't know, an apartment building or something like that where you can stack more organisms, more animals if you partition things up and you're not competing all for the same little area and the same food and everything else. And same thing goes with the way they feed and all that. So you'll cover some of that maybe in the ecology. All right, I'm going to hook this thing up. We'll do a little bit of sampling for probably 15-20 minutes. I'll need, like I said, a couple of people to help me out in the stream.
How bad does it hurt?
It definitely tingles, and you know it if you get shot. No. Do you like to dance? Like to dance? Let me see the batteries. I got batteries. What we were talking about, batteries are nothing. Shocking. 1, 2, 3. This will cover about half of you guys. I'll shock, and then I'll get. All right.
Can we go in?
No, guys. Come on out of there. All right. Keep these things up here. We're going to need these things to talk about. All right? Work with you. All right. Somebody help me. Hold that thing. Just like that. All right?